Hello, beautiful humans. Thank you again for joining Teach Jenn Tech. And today we have an awesome guest from Postman, Ian. And I'm very excited about this because you are like the one DevRel that I have met in person. And I'm like, yes, we met at the API Denver meetup last month. And Ian, please introduce yourself and what you're going to be teaching us today.
Sure. Hey, everybody. I'm Ian Douglas. I'm a senior developer advocate at Postman, and I'm on the clock. So I'll be here for a little bit. Yeah, shout out to my employer that lets me do crazy things like this. Um, let's see. I've been in the tech industry a long time. I joke I'm kind of an old dinosaur in the industry. Been doing this for 26 years. And I've had people on my live stream and people in my classrooms that are like, dang, you've been coding longer than I've been alive. It's like, yeah, thanks. Actually, this month, August, is the 40th anniversary of when my dad came home with a Commodore 64 computer. I was 8 years old, and that's when I learned how to code. I basically taught myself the basic programming language. So technically, I've been coding for 40 years, which is ridiculous to think about in and of itself. But professionally, I've been doing it for 26. And it's been a lot of fun just seeing all the different programming languages and seeing, the different technologies and things like that over the years, especially over the last 10, 15 years. So much has changed in the past decade, especially. So what I wanted to kind of go through today is, I know Jen's been learning some Python and also had some curiosity around JavaScript. And so what we were going to talk about today is like, what are some use cases for Python and JavaScript and how do they work together and so on. And so I've got a handful of things to kind of show about how I use Python and how I use JavaScript. And it's not just for JavaScript in the browser, and it's not just Python for, backend code. And stuff like that. So thought we'd dive in on a few of those things. I'll share my screen and kind of walk through some
Yeah.
of the little bits of code and stuff that I've been doing, maybe some stuff that I've been coding for work, and we'll have some fun with that.
I do have a question just because like when people say like back end, I feel like a lot of people can like conceptualize what front end is because it's mostly said about like websites and that kind of thing.
Mhm.
But when somebody says back end, is that talking about, let's say, on it's what's run on a server, or how would you explain back end to somebody that has no idea what it is?
That's a great question. I would typically classify it as code that runs on a server, where you don't necessarily have like a user interface, um, something like in a browser that someone is directly interacting with. Like when we work in the browser, we're generally interacting with the HTML, which then kind of interacts with the JavaScript. But then the JavaScript, if it has to like read and write things to a database, that JavaScript isn't directly talking to a database usually. It's going through like some other software, and then it's going to the database from there. And so it'll ping some other bit of software, which is what we call the back end of what we do. So the front end is like the customer facing or the user facing software, and the back end is like kind of what's behind the scenes. So we could almost use an analogy of like a restaurant where we have what we call front of house and back of house. And front of house is all the serving staff, where the back of house is all the people cooking your food. And so the people that you interact with as a patron of the restaurant, you're interacting with the servers. And so you're dealing with the front end of what happens in the restaurant. And then they go and kind of play sort of liaison between you as the customer and what actually needs to happen in the kitchen so that you have a good user experience at the restaurant. And so they go and they'll take your order to the back of the restaurant where they cook your food, and then they bring the food back out to you and sort of bring you back that result. And so when I talk about back end code, I'm usually talking about the folks in the kitchen who are, preparing all of that food or data in order to give back to the front end code to then give back to the user in some way. So if you fill out a form, the JavaScript front end might be processing that in a way that it can transfer that data efficiently to the back end The backend then is going to look through that data, maybe do some validation on it again, and then save that in a database. Or if you're trying to retrieve something, it's going to go get it out of the database, but it has to package that back up in a way to send to the front end. But the front end can't just, like we generally don't want to show you just raw data. We want to
Hmm.
format it in a way that presents well and looks nice and so on. And so the front end code will usually take that raw data coming from the back end and format it in some way so that it shows up as a nicely formatted list and so on for the user.
Very cool. I like the explanation. I also know that restaurants are also used very often as a way to explain APIs. So I feel like that is something that we can build upon another
Sure.
day.
Yeah, for sure.
All right. So you said that you have some examples because I think that's another thing of first off, like explaining like what front end and back end is, but like understanding like when you would use them and why.
Mhm.
And granted, the way I wrote the title on this was like, why use JavaScript versus Python? And I meant it as like, when do you use each?
Right.
And I think that's a really cool thing of, yes, JavaScript is used very often and can, a lot of people consider JavaScript easier to learn. A lot of people say Python is easier to learn. I would say no matter what, it's the first language is easier. The second language is really hard. And then the rest of them are easier because it's like you're comparing it to what you know on your second one.
Yeah, that's a good way to think about it. And some people think about programming languages a lot like spoken language, where the first one that you learn, that one is going to come easier to you because you have a lot of coaching around, like, learn to say your words, and then people help you
Mhm.
enunciate and how to put the grammar and the structure together. And when you learn that second language, you're kind of on your own. And you're right, it is kind of that comparison of, if I do it this way in English, I need to say it this way in Spanish.
Mhm.
But then once you learn a couple of languages, if you're kind of in that same sort of family of languages, like Latin-based languages, if you learn Spanish, you're probably going to learn French and Italian much easier, because of the grammar structure is the same, and a lot of the actual words are very similar, and so you'll start to spot those similarities and go, oh, if I do it this way in this language, I do it this way in this other language. And so it also translates well into programming languages, where JavaScript and Python and Ruby, they're what we call high level languages. They're interpreted languages, which means it gets loaded by some sort of processor that's then interpreting everything line by line in order to go run those instructions.
Okay.
Where compiled languages, they tend to do what we call strongly typed, which means if I make a variable, I have to define it as a particular data type. Like, this variable is going to be a string, and this variable is going to be a floating point number, and this variable is going to be an array, and that array is of integers. And that variable can only store that type. Where in
Okay.
JavaScript, we could say var, you know, whatever,
Mhm.
and we can assign it a value of 5, and later we can assign it a value which is a string, and later we can reassign it again as an array, unless we make it a constant. But if we make it a
Yeah.
var or a let, then it becomes kind of this fluid data type that we can change whenever we want. Python's the same way, Ruby's the same way. So some of these high level languages, they don't lock you into a type when it comes to how you declare a variable, and that allows for a lot of flexibility. But in these compiled languages, usually you have to set a data type saying this variable can only ever be a string. And if I need a variable to hold a number, I've got to make a whole new variable. And so it's good and bad, because it forces you into a better way of thinking about how you're actually organizing and storing your data. But then as you learn a couple of compiled languages, learning other compiled languages, it's just kind of like, oh yeah, okay, I need, the data type and the variable, and, integers are integers and floating point numbers are going to be floating point numbers. Is just, this programming language calls it int 32 or int 64 for, how many bits you're storing in that number, where something else is going to literally spell out the word integer, and another language might just say int for integer, and short form it a little bit. But at the end of the day, it's like you can kind of glance through that code and have a pretty good understanding of what it's doing. So if you're learning JavaScript, looking at other high-level languages, you're going to grasp probably 75% or more of what it's doing, because the structure of it is going to be the same, and the syntax and the grammar of what you're looking at is going to be roughly the same. So all these
It
languages, sorry, just one thing. All these languages have the same kinds of instructions, like how to iterate over an array and map and filter and things like that.
What are some compiled languages? Because you mentioned the other ones, but I just want to like
Yeah, for
think of.
compiled languages, yeah, I would think of like C++, Java, Go, Rust, things like that. Where with an interpreted language, like when I go run a Python script, I have to say, hey, Python interpreter, go run this script. And the first thing it does is it opens that thing and it scans through and makes sure the syntax is going to like actually sort of execute properly. And so it does kind of a quick scan for syntax errors, and then it goes through and it actually runs the code, line by line. In a compiled language, it does that interpretation one time and then compiles it into machine code, so that later you can say, hey, just go rerun that machine code. Something already scanned it and made sure that it was going to work properly, and then you end up with just an executable file instead. And then you can just go run that executable file as many times as you like. And so the initial time it takes to open the file or multiple files and scan through everything, and check all that syntax and make sure that everything is structured well, that only has to happen one time in a compiled language. Where in an interpreted language, every time you want to run that script, you've got to say, hey, Python, go run that script again. It's got to open that file, scan all the instructions, make sure it's valid, and then go
Okay.
execute it. But the nice thing about it is you can go in and you can change that script at any time. And then the next time I say, hey, Python, go make my lights blink in the background, it's just going to go update that and like blink my lights in the background. But in a compiled world, I've got to go change that source code, run the compiler process again, and that could take anywhere from seconds to minutes. And so it's a little bit slower process of getting that executable. Now that I have that executable, it's going to run really fast all the time because it doesn't have to go through that interpreter work again and again.
Interesting. So if I'm just comparing like Java to JavaScript, Java would have to be change the source code and be recompiled every time,
Mm-hmm.
where Java is much more lenient in letting us change things um, a lot faster and a lot quicker. But
So
it
JavaScript on the second one. Yeah.
JavaScript, yeah,
Yeah.
JavaScript. And what up, famous yak? Yes, the lights are so cool, aren't they? I love. I
They
want
make them
to.
blink and
Yeah.
stuff.
Oh, I heard you talking to last night about like wanting to put a warning on there, and I'm like, yes, I totally get that, but at the same time, they're so cool. They're so cool.
It's
I
it is
I
it
want to
is
do
pretty
that
fun, but
someday.
yeah. So what I was saying on my stream last night is like I want to either make them less bright when they blink, or slow down like how quickly they blink, or maybe just pick random ones to kind of like more twinkle, as opposed to like all 43 of them on the wall all like coming up with these random patterns, just for seizure trigger warnings. So
That's smart.
I'm probably going to do some combination of all of them, where I dim it a little bit and then slow it down and not flash like all 43 at the same time. Because right now it's actually going through and it's saying, hey, all 43 lights, pick a random number from 0 to 255 for red, green, and blue, set that panel to that color, and now go set all of them, and then do that again, set all of them, do that again, set all of them. And so that's why you get like this really rapid, like pretty wild sort of blinky thing. And that's all done in Python.
Yeah, and I think that's a really cool thing that like that's an actual way that we can use Python. Where before Teach Jenn Tech journey, like I'm like, yeah, I know you have to code it somehow. Just like it never really computed how to get started on that or anything.
Hmm.
So I know you have some things to show us today. So where would you like to start?
Let's see. Let's start with well, let's talk a little bit about like the differences between Python and JavaScript, and then we'll like maybe not in the history of them, but like where they're commonly used right now, and we'll kind of start with that basis. So I think most people understand, or if you've done some amount of programming, or if you've been looking into programming, you've probably seen or might have heard JavaScript is um, it's used very heavily, obviously, in browsers. So it kind of came to be back in the 90s, I think the late 90s, early 2000s, where JavaScript was invented as a language in 10 days. They literally wrote the JavaScript language in only 10 days and released it in the world. And it quickly became picked up in the browser as sort of like, hey, if you want code to actually execute in the browser, there's this JavaScript code. Now they borrowed from the Java name because then they're like, maybe we'll get some more adoption, because back then Java was coming up as a very popular language. Everybody was learning Java. And so they're like, if we call it JavaScript, then everyone's gonna like think it's related and they'll want to use it. And that's honestly where it got a big chunk of its popularity,
Are
was
they
stealing
similar?
a name. No, not at all. They're
Okay,
not
I didn't
related
think so.
whatsoever. No,
And
they're not.
Bakari says that JavaScript is his jam.
Nice.
I loved having him on the show too, but
That's great.
I'm glad you finally like I feel like I could have Googled it, but like knowing that's how JavaScript got its name,
Yeah.
in 1995 is when
95.
it
Yeah.
became
It's
first
been a minute.
release. It was integrated in Netscape Navigator 2.0.
Yep,
Oh.
really, really old browser. It's not even around anymore. And yeah, and Bakari Strawberry. Strawberry is my jam. Um, so that's how kind of JavaScript got its start. And Python's been around just as long. Python's been around for quite a while. The guy that invented Python actually modeled it after another programming language called ABC, which was built to teach kids how to code. And so his whole methodology of coming up with a Python language is it needs to be easy to read. It needs to be easy to sort of interpret and understand how it works. And um, we want to make it as easy as possible to get other people into that ecosystem. And so he spent a lot of time just making Python a very readable, easy to understand kind of language. Um, if anyone remembers the old TV show, Are You Smarter Than a Fifth Grader kind of thing, his whole mentality was like, everybody should be able to like look through a Python script and have a pretty good idea what it's doing. There were other interpreted languages in the day, like Perl, with like spelled like the precious stone without the A, Perl, and it stood for practical extraction and reporting language. And Perl was a very fast language. It could read through text files and crunch through data really, really quickly, but it was very hard to read. And so Guido is the name of the guy that invented Python. He wanted something that was going to process and handle things just as quickly, but also be readable. And so Python has been around for a long, long time as well.
February
Um,
20th, 1991.
yeah, yeah, it's been around 31 years now. 31 and a half years. Yeah, it's been
Crazy.
around a while. I've been using Python professionally for a little over a decade, and I've been doing JavaScript since the Netscape kind of days back, not quite 1995. I think I started learning JavaScript in like 1998 or so.
Okay. I
Um,
feel like this is where I get confused is like one of the popular questions on Google is Python built on C. And the response is Python is written in C. Actually, the default implementation is called C Python. And I'm
mhm.
just like, how do you write something on something else? Like it's a
So
language on a language.
yeah, and so if you think about, like, if you had to sit down and um, what would be a good example of this? If you wanted to write some code that translated a piece of text from English to French, you would need to open that file and you'd need to read it word by word and understand the grammar of what it's trying to do, and then figure out, okay, what's the equivalent for each of these words, and now how do I reconstruct that grammar and syntax in French and then rewrite that file. That's effectively what they're doing with C. Is they've got the C software. So C is a programming language. It's been around much, much, much longer, since the 60s, maybe 70s. I think 60s. It's been around a really, really long time. And basically what it's doing is they're writing instructions saying, hey, when Python interpreter opens a file and it sees these instructions, this is what we want the equivalent machine level code to do. And so they wrote the Python language using the C programming language. And it's basically, how do we write this interpreter where we're looking at the instructions piece by piece to try to understand what the programmer is trying to do with Python.
Interesting. And
Yeah.
hey, what up? Do I say your name? Can I, Philly Peischer? I hope that is somewhere close to right. Hello, and thank you for joining. And Bakari said, "Ogres has layers. Have layers.
Ogres have
Ogres.
layers. Yeah, it's a reference to Shrek.
Ogres have. Oh, okay. I don't. That's how you spell ogres.
OGRES. I didn't see
Yeah.
how they typed it. Yeah.
Oh, if you click comments, you should be able to see all of their comments too.
Oh, they're there.
Okay, cool. And then I looked up the oldest programming language, which is, do you know what it is? Just
The
curious.
oldest one?
The oldest one.
I feel like I should know it, but I don't recall off the top of my head.
Fortran.
Fortran. Yeah.
Yeah.
I learned a little bit of Fortran in college.
What?
Yeah.
Okay,
Yeah.
that's just kind of cool. Like I SQL is also a very is one as well, and that's just crazy. And you were absolutely right. Our on C, it was released in 1972. You said the 70s, so
Yep.
this is
Been a
just
minute.
cool. Also learning about the background of it.
Yeah. So a lot of people started using Python for more system level programming when it first came out, and like just general programming of, let's make a little game, or let's figure out how do I look through my file system and get a list of files and do something interesting. And so there's going to be a lot of um, like system level things that you'll see like historically in Python. And so the main sort of library that you see happening within Python is going to have a lot of different things. Somebody just did something on my stream, which is why all my lights went a little haywire there for a moment. But for JavaScript, the default things that you're going to see in JavaScript are, here's how to do things in your browser. Here's how to interact with a button. Here's how to fill out a form, or how to interpret things that somebody has typed into a form. And it's sort of the not the necessarily the default, but like this is where we most commonly use this language. And so Python got its roots in system level programming, but of course it's used in so many things now. You can get into like it's heavily used in machine learning and data science. And it's
Oh,
also used
okay.
quite a bit for backend servers.
Mm-hmm.
But if you need a backend code that's really, really performant, you're probably going to rewrite, like you'll start with a prototype in Python because it's very quick to write. But then you're probably going to rebuild it in a compiled language, which is going to be more performant, depending on your needs. Some people will write something in Python and leave it in Python forever, and it'll work just fine. Not everything has to be built at like, what we say Google scale, or like, scalable to millions and millions of users. Chances are pretty good if I write a dad joke API, it's not going to be used by millions and millions of users. It might be used by dozens, right? So I don't have to
know.
go.
I would share that one a lot. I definitely would share that one.
Yeah, I mean there are some that are very, very heavily used, but again, if it's a dad joke database, you don't necessarily have to build that out at Google scale using compiled languages and whatever, because it's just a static list of jokes. And when somebody calls the endpoint saying, give me a joke, you're just going to give it back something that you've probably already holding in cached memory. So it doesn't even have to be really that performant, as far as like how you build out that code. And so, Python today is being used for a lot of data science and number crunching and machine learning and stuff like that. And it's very, very effective in those roles. JavaScript, on the other hand, has kind of worked its way out of the browser, and you can also do some interesting things with that language as well. And so a lot of these programming languages nowadays are really like general purpose languages. Like I can do system level stuff in JavaScript. I can do web based stuff in Python now. Someone actually wrote an interpreter in JavaScript to interpret Python code. And so now we could actually be writing Python code in the browser,
That's
to do
fancy.
what JavaScript is doing. Yeah. And that's all they did. So similar to how the original developers of Python wrote it in C, someone else has done that work in JavaScript. So now I can write a chunk of Python code and it'll actually sort of translate it into JavaScript for the browser to actually execute. So very similar to what the C Python is doing, where it kind of builds that Python interpreter and compiles it down. They've basically done that in JavaScript. Now it does add another layer of complexity because when I write Python code, it's got to go through that interpreter and then into JavaScript and then to the browser. And so there's a lot of extra steps. And so it's not going to be as fast as writing native JavaScript. Just like writing
Um,
Python code isn't going to be as performant as if I wrote that code in C.
is it something that if they're writing it in Python, that after it's compiled and put into JavaScript, that they could copy and paste the JavaScript and just use the JavaScript? So that way it runs faster instead of making it more complex.
Maybe. I mean, there are tools out there that will do something like that, and we call it not really compiling, but we call it transpiling, where we're
Transpiling.
taking
Okay.
something and we're translating it and compiling it at the same time, and then we have some kind of result at the end of it. So, like as an example, TypeScript is another form of JavaScript, which is getting into that strongly typed language that we were talking about earlier, where TypeScript is going to basically compile down and transpile down into the actual native JavaScript that the browser needs. And so there's been a lot of work around how do we build the libraries and so on to actually build TypeScript that when we compile it, it's actually compiling down into JavaScript to then run in the browser. And so you're writing it in TypeScript and it's going through all the interpreter stuff, but the browser's not reading and executing TypeScript. It's got to be sort of rebuilt into JavaScript. And in that case, you could actually go look at the resulting JavaScript. I'm pretty sure with this Python version, though, it's actually just running all in the browser, and it's not actually compiling down in a way to actually then go view that JavaScript. It's just kind of interpreting the instructions and building the equivalent JavaScript instructions instead. So it's looking at the
Hmm.
code going, if they do a for loop, then I also want to do a for loop that looks like this.
Interesting. That is complex yet simple at the same time. And this is where I keep getting stuck in learning programming of like things can be very complex and simple. Like it's a thin line because it's
For
like
sure.
if you think about it more, the more complex it can be, even though the bare basics are pretty simple.
Yeah.
Uh, okay. And also learning so much of the time of like when these languages came out and also building upon each other. I see that you have your screens. Let me bring that
Yeah.
up.
So I've got a handful of different bits of code that I can show, like how I use JavaScript and how I use Python, just for some of the stuff that I do on a regular basis. So this first one is a little API that I wrote, and this also has a bunch of Python code in here as well. So this is a little jukebox voting app that I built, and basically what it allows you to do is it's an API. Well, there's two parts of it. So the back end is actually an API that you can hit where you can say, I want to vote for a particular genre of music as well as a decade of music. And so while this
Okay.
code is running, it's capturing people's votes over an API. And so I wrote this because we were doing a partnership event with this company called InfoBip, and they were traveling around the United States, and they wanted some kind of way of like showing off what their software is capable of. They're a little bit like a Twilio, where they can do SMS and chatbots and email
Okay.
and all this kind of stuff. And so I'm like, I like chatbots. Let's build a chatbot in InfoBip. And so what it allows people to do is you can go in and using an SMS chatbot, you can say, I want to vote for rock in 1990, and it would
Hmm.
register that vote. But then I wrote a front end for it that basically queries the back end saying, give me all the votes. And it'll actually start playing a song based on which vote is winning. And so it
Oh,
sounds a
that's
little bit like
cool.
a radio tuner, where someone's like hitting the button, to play a different song.
Yeah.
And so whichever song is winning, it starts playing a fragment of that song. And if somebody else's vote starts to, they got more votes for, say, pop music in 2010, it'll skip from playing, Journey from 1980 to Taylor Swift in 2010, and it'll actually change the song at that point. And so
It
it sounds
reminds me of like a play now on the jukebox.
yeah, it's basically what it is. But imagine like if you're driving in your car and you're just changing the radio station, and like people can't agree on like which radio station to listen to. When you hit that button, you're going to go back and listen to that other song, but time has
Mhm.
progressed, and so the song has also skipped ahead, and that's basically what this code is doing too.
Oh,
Is
okay, that's cooler.
it's effectively starting all the songs at the same moment, but then as one vote, so they're all playing at the same time. But like right now, Journey is winning, and so
Oh,
it's playing Journey. And then later on, if Taylor Swift wins, it changes as if somebody hit the button on the radio to change to the Taylor
so
Swift
if
song
you're
at
two
that point.
minutes into Journey, you're 2 minutes into
You're two
Taylor
minutes into
Swift.
Taylor Swift, yeah. And
Oh,
then yeah, so it
that's
was really fun to
bananas.
yeah. So the API that I built out is literally just go collect some votes, and so it's storing everything in a Redis database. But they can call an endpoint to just say go get the list of instructions, where I'm saying here are the list of genres and the list of decades. I can zoom in on that a little bit more if folks
Thank
need.
you.
Um, and and so, yeah, it's looking at how I've set up my music for this. So if I have music set up in a particular way where I've got like rock music and pop music, I can go run my jukebox player using that structure. If one of my coworkers is doing an event and they want hip hop and jazz, they can set up the song structure that way. And so the front end player is basically looking at how you set up your music structure here. So in this case, I had rock music and pop music. And so you set up a folder structure saying these are the songs. And then it goes through and it takes that song and it actually breaks it out into all these 3-second segments. And so when that vote changes, what it's doing is it's saying, okay, well, we're 30 seconds in. So that's 30 divided by 3 is 10. So I need to start playing fragment number 10 of this
Oh,
particular song.
interesting.
And so the front end is basically just going through, and it's constantly polling that API to say who's winning, and then it goes and plays that fragment of whichever song is winning. So the back
Interesting.
end is literally just storing the votes. So if we come back over here and look at what's happening here, I can go in and I can reset all those votes. And this is all written in Python. And so this is a library called Flask, and it's just the back end code of how do I receive a vote, and then how do I go get all the stuff out of the database to give this data back. And so if they call just whatever my host name is with a slash, it's going to give them back the instructions on how to use the API. If they vote, this is an endpoint to actually go get a vote. They have to give us the genre of music, so rock or pop or jazz or hip hop or whatever, and then the decade of that music as well. And then it registers both of those votes in the database. And then later on, it'll say, okay, go get all the results, like who's actually winning the vote. And all it does is it goes out to the database and grabs that data, and it just gives all that back. So on the front end then, or what I'm calling the front end, is just a command line script that I run. And this is going through and saying, okay, well, let's go, set all this stuff about, where to actually go find the fragments of the songs. And then, let's see, somewhere in here, I'm actually calling the API. So this is just doing the setup of like, go figure out which fragment of which song to play. Doing some Postman authentication as well, because we were doing all this stuff in Postman. So this is where it's saying, okay, go figure out who my current winner is. And so this line of code in Python is using a library that says, hey, just go call this API or go call this web endpoint. Just give me back the results of what you got. And so it does all of the hard work of how do I connect to that server? How do I send that request over? How do I get data back? And put that in a result object. And then I say, okay, well, that result is JSON. Now go figure out who the winner is based on what the winner is and the decade of what's winning. Go figure out that MP3 file and start playing that next. And so it's
Okay.
queuing up all these 3-second segments. and it's pretty fun. You go to a meetup and you're like, all right, everybody start voting for your music, and we're going to start playing it as we go. And it would start playing all these little fragments of music, and then people are like, oh, I don't want to listen to like Bon Jovi. I want to go back to Whitney Houston, 1980 pop music or whatever. And as they vote that over and over and over, that vote count starts to climb, and as soon as that one starts winning, it'll switch to that song. And so it's really fun. Like the first couple seconds is like, okay, well, everybody's voting for Journey, but like, oh wait, it just changed to something else. Wait, now it's back to Journey. Now it's back to something else. And so it kind of hits this critical mass of people are just like, no, I want to vote like over and over and over and over and over. And so it was a lot of fun to build this out. And so this is just a command line Python script, which is going out to the file system and saying, go get that MP3 file that I've got on my file system somewhere and just start playing an MP3 file. And that's all just done in Python code. So it doesn't have to be what we consider backend. This is just system code.
So, and I think that's maybe just like the part that I may not comprehend yet is when people say like Python command line. And yeah, just like when you put it in your terminal, I don't know where I'm necessarily getting mixed up, but so command line is written in many different languages, not just like a bash language. I'll go with that.
So when we open the terminal, it's running a shell, and that shell is an interpreter, very similar to a Python interpreter or a JavaScript interpreter. It's basically watching all these commands that I'm typing, like the word source, and behind the scenes, it's interpreting what I'm writing, and it's actually going to go, do some things at a machine level to say, what is it that Ian's trying to do here? In this case, I'm trying to activate a virtual environment. And so Bash, in this case, is my shell terminal, is just an interpreter. It's watching the instructions that I'm manually typing in and saying, okay, you type the word source. That means that whatever follows, I need to actually go execute that code. And that code is basically saying, go set up my Python virtual environment so that I can actually come in here and say, now I want to run my Python interpreter to go do my jukebox player. Is in jukebox player, and I can say Python 3 player. And now this would actually be, playing my jukebox player at this point and connecting to that API and trying to figure out who's winning. And then it starts playing the MP3 files in the background based on who's winning. And so I don't know if you can hear the audio. I don't know if when it shares my screen, if it shares the audio or not. But what it's doing is it's basically going through saying, let's see if I can stop it here. It went through and it basically was running through and figuring out like who was winning and then like playing the audio segment of that file.
Very cool. Interesting.
And so that just runs in a terminal. And so the actual player just runs in the terminal. The backend code that I wrote, the actual API, is actually running on Heroku. So it's a hosting platform where you can send, back-end code and front-end code. And they're actually running that API for me over at Heroku. And so my code started up, it pinged over to Heroku going, hey, are you awake over there? Go tell me who's winning the vote. And then it started playing the audio. So I could hear the audio on my side, but I guess it wasn't being shared. So that's one example of how I do Python code. I use it for backend APIs. I also do a lot of system level programming. And another thing that I do quite a lot is my Twitch chatbot. So if anybody ever comes and follows me on Twitch,
it's so fun.
I've got all kinds of stuff written in here. So this is my static content. Let me go find like static responses, for example. So if you ever come over to my Twitch stream and you type !ANON, it'll basically give you back this instruction in chat saying, hey, if you ever want to ask a question on my channel and you want to ask it anonymously, here's what you need to do. Or if you want information about my audio podcast, you just do !podcast and it'll give you back this static response. If you want a funny greeting, you do exclamation point hello, and it'll randomly pick one of these and send it back. And so this is all Python-based code, and
Okay.
it's using someone else's library to actually connect to Twitch and watch the chat for somebody typing in these commands. And then it's also interpreting what people are writing. And so I kind of wrote my own interpreter inside of this as well. So if I go pull up my actual chatbot, let's see, it's my prod bot. I'll show you an example here. So what would be a good one to show? A good one is going to be like when people want to change my lights here to a different color. So you can actually come into my chat bot and you can redeem channel points to say like set this to a particular type of pattern or whatever animation on the lights. And so what it's doing in here, see if I can find it. It's leaf. Let's see. Oh, where does that actually get interpreted? There it is. So it's actually calling this blink. If they try to make it blink, otherwise it's interpreting what they type in. And so I'm actually breaking their command down into multiple pieces to say, what is it that you're telling me to do? And so if they're typing in the word random, then I say, okay, I'm just going to go set it to one of these random effects. If you don't give me a list at all, it'll give you a list of the effects that you could set it to. And so I'm basically breaking this down piece by piece to say, what is it you want me to do here? And so I've basically built my own interpreter into my chatbot so that when you're typing things in, it can interpret what you're trying to do. So this is all written in Python.
Did
And
you did like Nanoleaf come with anything that like described that you could do this, or like
they
how
have an
would you
API.
know?
Yeah, they
Okay, they
have a
do.
public API. Yeah, and then there are people that have written Python libraries for how to interact with that API. So I don't have to, figure out how do I talk
Okay.
directly to Nanoleaf. I'm going through another Python library that someone else has already done that work and tested that everything's working properly. And so I just connect to that library with an IP address saying this is the IP address of my Nanoleaf thing, on my home network, and then it knows how to send all the instructions back and forth.
Very cool.
Um,
And everyone, I just linked Nanoleaf in the chat because this was one of the biggest things when Ian and I first chatted of I love that I was so captivated by these lights last time we talked, and now seeing how a practical use case for Python in since I've been mainly focused on JavaScript, that it's really cool to see the difference and looking at a lot of the different code, even though at this point I'm like, I can kind of guess what everything does,
yeah.
but it would definitely be helpful to like, have the documentation with it or
Mhm.
something like that. So this
And
is
that
this
kind
is
of goes back to what I was saying at the beginning of the stream. Like once you learn a couple of high-level languages or even one high-level language, you can look at this and you can probably guess what all of this stuff is doing. I'm doing the same kind of imports here that you might do in JavaScript, where you're
mhm.
importing a third-party library, and then I'm running some instructions here. This is how I'm connecting to my Nanoleaf. And then I'm telling it like make sure everything gets powered on, so it'll actually turn on the panel of lights if it's not already on.
Okay, that's cool.
Um, this is just me like watching like old settings and things like that. And then guess what it does? It sets the
Uh,
brightness to a value of
ooh,
34 of 100 and
and
do that over the course of 1 second.
okay, so that if we're looking at this and we wanted to change, you said to put the lights in a slower speed, would we be
Mhm.
changing it right there for in 1 second? Oh, no, you have a
No,
timer.
that's happening somewhere else. So this is the code that actually says go find a random red, green, or blue value and
Hmm.
then send that back as a data structure that we call a tuple, which is kind of like an array of
Hmm.
red value, green value, blue value, and it's got all the values between 0 and 255. And so I can set each one of these individual panels to a combination of red, green, blue. So what's basically happening, this is the script that runs when I hit a button on my Stream Deck that says go blink the
Hmm.
lights. And so the timer here is really kind of a count of how many times it's flashing, but basically
Okay.
saying we're going to count down those 60 cycles and then say, okay, for every one of those panels, go pick a random color. And then I want to set that panel ID to be that color.
Okay.
And then it's saying, okay, now that we've told all 43 of those panels to get ready to set itself, I want to go synchronize that, and boom, they all turn that color.
That's
Now,
cool.
to slow it down, all I need to do is add something in here that says I want to sleep half a second in between each of these. So if I save that and I try and run that now, it's actually a little bit slower on that blink. Actually, let me
So
go
what
run that one.
happens if you did sleep, like, would it be like a 10 to make it that much slower, or would the 10 make it faster?
It would make it slower. So that's telling it like how many seconds to wait. In that case, I don't think it actually ran that one. So let me. Oops.
And so far, I know we've had a few people in the chat. Anyone have any questions? Because this
So
has
notice
just
how.
been answering my curiosity
Yeah, no, it's all
questions.
right. So notice how much slower they're blinking now. That's because I've
Hmm.
introduced that timer saying like after setting them all to a random color, sleep half a second and then go do all that again. And it's doing that 60 times. And so what was happening really fast is now taking much, much longer to run. But these are all the different effects that I could set it to as well. So I'm actually querying my Nanoleaf saying, how many panels are there? What was the current effect? It was this Nemo effect, which is just the orange and white in the background.
Yeah.
And so what happens is it goes through that process of like, go make them all blink here and then set it back to the old effect and whatever
Hmm.
the original brightness was. So again, what I was talking about at the beginning of the stream is I want to kind of tone down the brightness if I do make them flash. So it's not like this really bright, vivid sort of thing. Because I could come in here and I could set this brightness to be a value of 100. And if I go run this again, you're going to notice these lights are like it's going to be wildly bright in the background,
Oh,
like to the
yeah.
point where it becomes hard to see through the camera what color it actually set. But like,
Hmm.
it's reflecting off a painting and stuff back here. Like it's
Hmm.
really, really bright in here. And so if I wanted to be more sensitive to the folks on my stream, I would say, okay, well, let's tone it down. Let's do like a 20 where it's going to be a more like muted sort of color. And so now we see that it actually
Oh,
faded down quite a lot more. And
yeah.
so understanding like, hey, like I want these lights to flash when someone comes in and follows or something, but I don't want it to be this huge, like overpowering kind of thing. Well, now that I've slowed it down, doing 60 cycles of all those colors takes a long time. So maybe I'll bring that down to like only 10 color changes instead. So I can come over here, I can stop the script, I can run it again just to see what kind of effect that's going to have. 5, 6,
That's so
7, 8,
fun.
9, 10, and then it stops and it goes back to what it was when it last ran. Well, when it last ran, it was set to some random color. So that's why it'll be kind of left on
That
that. So now I've slowed it down and I've made the colors more muted, and so now and it won't take as long to flash either. So
that is so cool. And Bakari said that Python is such an elegant language.
it is,
I
and like I said, the guy that invented the language wrote it to be easily readable and easily understandable, and so there's a whole team of people at Python that are basically looking at changes that people want to make to Python, and they make a decision as to whether or not, yes, this is a good change to make to Python around this whole idea of there should be one way to do a thing. There can be multiple ways of like looping over an array, but really we want everybody to use this one way to do it. So that way, when you look at other people's Python code, you have a pretty good idea of what it's doing because everybody kind of does it the same way. Now you can go off and you can write it your own way in Wild Wild West, the thing. But they really do want everybody to write Python the same way so that anybody else reading the code has a pretty good idea of what's going on and what's happening. Yeah.
does uh, Python have frameworks like JavaScript does,
Yep. Certainly does. Yep.
like on
The
Anaconda and I don't know why I'm saying that word so weird right now.
Anaconda.
Yeah.
Anaconda is, I believe that's one of the data science, data processing, data analytics libraries. So it'll
Okay.
do a lot of the heavy math, from what I recall. Um, so yeah, so the API that I wrote for the jukebox player is written on a framework called Flask, and it's a very lightweight framework, and it's used a lot with APIs. Um, if you want like a full blown like web application, you can use a framework called Django, which starts with a Django, and it's a full blown like it'll build out like admin panels
Oh,
and like
wow.
let you talk like to databases and like pull up, like it's really quick to prototype. I've got this database structure, how do I make a form out of that database structure, and
Hmm.
it'll interpret what you've got defined in your database, and it'll automatically build forms for users to input data and things like that. It's a very powerful framework.
Oh, that's
It's got a
cool.
pretty steep learning curve, but once you learn it, it's very, very effective. So yeah, there are frameworks as well. And then, on my stream, like I do a lot of Q&A around like career prep and interview prep and things like that. And so I've got all these other Python scripts and shell scripts of, how do I go do all these other things to then process my video files into smaller videos for YouTube and stuff like that? Or how do I go extract the audio to actually go then upload MP3 files for the podcast audio stream and stuff like that?
Oh, that's
Um,
cool.
yeah, and so that's all Python and shell script. But what I wanted to show is that we can also use JavaScript for non-browser things. So what I wanted to show you here is how I use JavaScript on one of my websites. So this is my techinterview.guide website that I do my live streaming about. So if you go find Ian Douglas 736 on Twitter or on Twitch, you're going to find this website. And it's basically my career prep advice. But one of the things that I do on here for kind of transparency reasons, I want people to know when I've last updated something on my website. So for
Hmm.
example, if I go over to here, if I go to techinterview.guide, I have a change log on here. And what this
Oh,
change log is
cool.
like, what have I last changed on the website? And so, the last time I actually pushed something in this, I was like updating my financial transparency, because all the money I make as a streamer, I put into a diversity and tech fundraiser, and then I match that money. And so I wanted to make a change log that, could people go see what I'm actually doing on the actual website for career advice. And so in the past, in the change log, it's been like, um, I was working on the actual book format and things like that, or I put all the cover letter and resume notes in the wrong spot. And this was mostly so that people could say, like, I haven't been to Ian's website in a while. Has anything actually changed? Like, do I need to go through these chapters and look at anything new? And so what I wanted to do was find a way of like, could I grab all of my Git commit messages and build that into a web page?
Oh,
And
that's
so this
cool.
so this is in JavaScript. And that was partly just to stretch myself a little bit. And so I have this markdown file called changelog, and this is where it's going through and it's actually building, it's fetching all of my Git commit messages and building this as markdown, and then that compiles into HTML using another process. But what I have in here is I've got a script called changelog.js. And so when I go run this on the command line, it's basically building like kind of an intermediate version of it, where I said, I wanted some transparency about like when I was actually changing something tangible about my website. And then it's going through and saying, okay, well, go find all of my commits as of basically November 2019. Like, stop looking at any commits older than that. So if I really wanted to say like only grab like the last 50 commits or something like that, then I
Hmm.
could set a date or something, or like I haven't really tangibly changed anything since this date. But otherwise, this is going through and it's saying like, go get all of my Git commit messages. So let's walk through what this is doing. So the child process is basically saying, I want to be able to go out to the shell and go run some kind of shell command and then give me back that result. And in order to do that, I also need access to the file system. And so I'm requiring in some JavaScript libraries for this. And then I'm just going to go call git log. And I can literally come in here and I can just call that command myself on the terminal and see what my JavaScript is going to get back. And so when I call git log with that, let me pull this up here. it'll actually show me here are my commit messages, and then showing me the date with this delimiter. And I'm basically forcing it in there so that I can parse things a little bit easier with like a known delimiter value that I can go in and extract these strings basically. But here's my git log with all of these delimiters in here. So, I wanted to basically take this whole git message here and say, okay, I want that to show up on this change log. And so I say, okay, well, go run that as a child process. Go do all of this, give it back as this UTF-8 character type. So there's different ways that we can interpret characters and things like that as strings. And then saying, okay, now in all of that output, I want to split it on that delimiter. And then I want to map over all those results. And I want to, figure out the message and the actual date of that message. And I build that into a data structure, and then I iterate back over that data structure to say, okay, now I want to go read this file, and how do I then go over all of those commits, and then say, okay, well, if it started with this, so this is what I was doing is I was actually, I was saying, like, as soon as I see a commit with this date, I throw an exception that says stop working. Like, this is as far back as I want to go in my git
Okay.
log. Otherwise, if I have a commit message that starts with the string like rebuilding the site, it won't put that in there. Otherwise, it's going to go build all this stuff as Markdown, and then if there was anything to change, then it goes and it creates that change log file that we looked at a moment ago. So it pulls this one up as kind of like a early processing version of it, and then ultimately writes it into this changelog file here, which is all written as Markdown.
Interesting.
And then I run another process that says, hey, go through all these folders, find all these Markdown files, and convert them all into HTML. And then I upload that to the website. So whenever I do a git commit, I then run this this command here, so I can come in here at any time, and I can say node changelog.js, and it just went through, and you notice it changed something in here.
Mm-hmm. That is so cool. And I like what Bakari said. Wow, what a guy. Yeah, you've
Yep.
built this out pretty cool. I will say, like, imposter syndrome, I'm like, dude, I can never do that. And Ian did share that it's taken him a while to get this done.
Yeah. Yeah,
So I am
you know,
grateful for you sharing
part
that.
of doing this changelog in JavaScript was to stretch myself of like, I want to see if JavaScript can do system level programming. And I actually wrote this script like long time ago, and I haven't had to change it, thankfully. But JavaScript can be used for non-browser code. And Python can be used for a lot of different kinds of things as well. It's mostly going to be used as backend code and system code for Python. But now in JavaScript, we can also do system level code. And you can do backend code if you
Interesting.
use a framework like Node and Express. You can also build out full API backends as well and talk to your database and process data and all that kind of stuff as well. So there's lots of frameworks out there that you can go do this kind of stuff with. And the nice thing about these high level languages is you can use them for a lot of different purposes. You shouldn't have to feel like, oh, if I'm learning JavaScript, I can only do stuff in the browser. It's like, no, you can
Mm-hmm.
certainly do stuff in the terminal here as well. There's lots of ways that you can use this code and interpret this code to go run and execute. Now, is JavaScript the best tool for this? No, not necessarily. I could have probably done most of this just in regular shell script coding as well. But like I said, I wanted to stretch myself into how can I do this with JavaScript? Like, it may not be the best tool for the job, but for me, it was a learning experience. And I've been a big fan of like learning in public and seeing how I want to do things, and how things actually run and execute. And it expands my appreciation for what goes into the JavaScript language by building a script like this, to where I can say, oh, this isn't just about like go interpret these values on a form and like, do a fetch and, process stuff in a browser. Like, JavaScript can do a lot more than that.
I love that. And I was looking really quick just to see if like what the documentation would be. It doesn't let you see very much before logging in for Nanoleaf, but I'm like, I almost want to get Nanoleafs and be able to see if I can like program one in JavaScript and then program one in Python just to like compare the two in the process.
I'm sure somebody has written an npm package for that.
That's
Yep.
what I was just about to look up because I was like, well, it's not really letting me see it, so I'll look it up later. But
Yep. So yeah, you want to search for something like Nanoleaf client or something like that.
okay,
Now I'm not necessarily endorsing that one, but that's
yeah,
effectively
something
what
like that.
what you want
Yeah.
to is you want some client level software to talk to your Nanoleaf. But Nanoleafy JS looks like API client and command line tool. Now that's specific to one particular kind of Nanoleaf. So let's go look at this Nanoleaf client one real quick.
And Nanoleaf isn't sponsoring this either, but I mean,
Nope.
if y'all do one point, please reach out. I will have more lights everywhere. I will completely redo my background for
Yep.
Nanoleaf.
So this one operates very similar to my Python script, where it can try to discover like what is the IP address of your Nanoleaf, but it should probably have a way of like because this can actually take a little while if you've got a lot of things on your network. It's going and pinging all of them, going, do you know how to talk Nanoleaf? Do you know how to talk Nanoleaf? Do you know? Oh, you do know how to? Okay, this is the IP address I need to use. But if you've got multiple Nanoleafs, which one does this actually talk to? Like if
Mm-hmm.
you've got several of them, then you want to be able to talk to each one. So you would have to know the IP address, but otherwise it's the same thing. You have an auth token, and then you can go get information about it. You can get the orientation, which is literally like how they're sitting on the wall, and things like that. You can get the saturation value, turning it on and off, setting your brightness, setting the duration of like fading that brightness in and out that we saw. Getting and setting the hue, which is basically a single color value, or setting, the effect, like the Nemo effect. It was just the orange and white in the background. Or you can set like an actual like RGB value or HSL. I forget what HSL stands for. But then they give you full examples of, yep, here's how to talk to your Nanoleaf on an IP address given your auth token, and then based on that, go get your information and then go run those other commands. So
I love
I mean,
this.
if I were going to do this again in JavaScript, I'd probably use this library. This one looks pretty well documented and pretty straightforward to use.
Thank you for joining, Bakari. Good luck. He just said that he has an interview.
Oh, awesome. Good luck. Yeah, I hope it goes great. Let us know how it goes.
And this is so
So,
cool. You've
yeah,
taught me so much in such a short period of time of just like everything that can be done.
yeah,
Like the possibilities. I feel like that's a hard thing for newbies of seeing the possibilities
yeah.
where I liked that you I don't know where I saw it, if it was on your Twitter or you actually talked about it yesterday of suggesting that people can reach out to you for ideas. And I'm like, for like something to program for
Oh,
like
for
younger devs.
project ideas and stuff. Yeah.
Yeah. And I
So I
was
have
like,
a
that's so smart.
I have a Discord community, and actually somebody posted in there last night going, I've got to build my 100 hours project for 100 devs, and I don't have a project idea. And I'm like, here's what I would do as a project. And basically what I told them, I can pull it up here real quick. What I suggested to them is here, like the general concepts of what you should build out that will make you stand out as a candidate is you want something with authentication, maybe form data processing.
Hmm.
And so I came up with an idea of like, just make a simple, you can log in, you can build a profile for yourself, and you can go visit other people's profiles. And if you're not logged in, then what you see on the profile is very limited in scope. And so this teaches you all about authentication, like who
Hmm.
are you, so that you can build your own profile. And then it talks about authorization, which means if I go look at your profile, I shouldn't see the edit profile button. Only you should see that when you're logged in.
Right.
And if neither of us, like if no one's logged in and they go to your profile, maybe they just see like your name and your profile picture, and they don't see all of the other content that I would see if I'm logged in, because if I'm logged in, I'm more trusted with that data or something like that. And then maybe for your profile, have a way to like upload a picture. And then where do you store that picture? Like, do you put it in an Amazon S3 bucket or something like that? Um, these teach you some very fundamental things about web development and how the internet works. And so having a project that sort of encapsulates all of those things makes for a really good project, because then you can expand that out to whatever you want it to be. You could build like your own little news feed, make your own little
Hmm.
social network kind of website or whatever. But by having the login and having the profile page and having that authorization of what are you allowed to do on that page, you could build out a search where you say, okay, well, go find users who have Ian in their name and only show me them.
Hmm.
Well, if I've got thousands and thousands of Ians on my website, I don't want to list all of that on one page. So what if we did pagination and we only show you like 10 or 20 at a time?
Hmm.
Well, that's also teaching you about database operations and how do we only grab like a little bit at a time. And so the concepts of building a project like that, which you can then expand out into whatever you want. You could turn that into a shopping cart website. You could turn it into like a book lending, between friends kind of site. You could build that into like whatever, like let's plan a road trip and go see what the weather's going to be like when we get there. Like you can do all those things of like,
Yeah.
here's Ian's profile and here are all the road trips that he planned. Those kinds of things. Like you can expand that idea out into whatever else you want. But these are the kind of the core fundamentals, I think, that will really stand out as opposed to, I made a to-do list application. It's like, okay, that's good because it still shows that you can write a user interface and you can store things in a database. But if I need somebody to be logged in on, at my company, like our customers have to log in to do something. If you don't know how to do that, I've got to teach you all that authentication and authorization stuff. If
Hmm.
you've already got a project where you've walked through that and you have that understanding, that's one less thing I have to train you on.
Hmm.
And that makes you look like a better candidate for that job. So by building a project where you've got some of those core fundamentals in place, it makes you like sort of a better candidate overall, as
Yeah,
far
I
as
get
like
that.
me wanting to hire you, because I've got fewer things that I have to sort of train you on once you start on the
Hmm.
job.
I totally get that. And there's just so much that goes into it. And I think that's the exciting yet overwhelming part of
For sure.
the tech world in general and coding and all of the possibilities. But any last things you want to go over before we end today? Because we've gone through a lot of like
It's been a
when
lot.
Python and JavaScript both came out, how they originated, just going through a lot of the differences, as well as seeing some use cases on both.
I think the biggest piece of advice that I give to folks who are just learning technology and learning about programming is study one thing and know it really well. So if you're learning JavaScript, learn how to do all these things in JavaScript. Learn about how to run things in a terminal, how to like connect to, Internet of Things lights. I mean, if you
Hmm.
can get like a $10 light bulb on Amazon and learn how to control that, through Internet of Things libraries like Nanoleaf. You don't have to
Yeah.
go buy a Nanoleaf in order to do that. There's much cheaper alternatives out there where you don't need to buy a whole panel of these lights, because you can't really just buy one Nanoleaf. You have to buy like a whole set of them, and they could be hundreds of dollars. But you can go buy like a single light from a company called Govee, Govee, and they're very inexpensive, and you can get literally just a light bulb and you can interact with that API that way. And use Postman for that. We've got all kinds of fun stuff in Postman that you can interact with these libraries. But when you're learning a new concept, it's easier on your brain to learn one language and learn that really, really well, and then figure out later on in your career, like, okay, I've learned JavaScript. Excuse me. I can do all this stuff in JavaScript. I want to go a little bit deeper. What else should I learn? Excuse me. And so at that point, you can make a decision on, okay, now I think I want to go dabble in some Python or Ruby or
Hmm.
Go or Rust or whatever. But I think what holds a lot of people back in tech is they see these job posts and they're like, oh, I can't even apply for that job because I don't know all 15 or 25 of the things that they're asking for. So I need to go learn all 25 of those things. Well,
Hmm.
by the time you go learn all those things, that job post isn't even around anymore. And
Hmm.
now when you go look at somebody else's job post, it's a completely different list of things. And you're like, well, now I got to go learn all that stuff. And so you never really feel ready because you feel like you've always got to learn something before you can even go apply for that job. Where if you just go really deep on a particular technology stack, then you can say, okay, I know JavaScript really well. I'm just going to go do JavaScript. I'm going to go do that interview in JavaScript. And yeah, maybe I need to go learn Python to actually get that job, but I understand the programming concepts and I understand how to do all these different things in JavaScript. I just need to go figure out how to say that in Python.
Hmm.
And so
Okay.
again, if you learn Italian really, 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 really well, you're going to be able to understand some bits of Spanish, and you'll be able to pick up the Spanish language really quickly.
Hmm.
And then once you learn Italian and Spanish, picking up French, like you'll pick up French in like a week, because a lot of that grammar is the same, and a lot
Hmm.
of the words are the same. You just have to learn how to, maybe there might be like a few differences here and there. Same thing with a lot of like Germanic languages and so on. As you learn German, you'll learn like, Czech, and some of these other languages. They're not identical, but
Hmm.
the structure of how those things get put together are going to be very similar, and it'll be the same way with programming. But I would say early in your career, when you're just learning this stuff, focus on fewer things. And so
Hmm.
I talk about breadth of knowledge and depth of knowledge. As a hiring manager, I would rather hire somebody with a depth of knowledge than a really broad breadth of knowledge where you only know things a very shallow amount. Like if the only thing that you can build in JavaScript is a to-do list application, then if I say, go build me an app in Python, you're like, I'll go build a to-do app because I know how to do that. And then if I say, go do it in Ruby, you're going to go build another to-do app because that's all you know how to do. But if you go really deep and you build a bunch of projects in JavaScript that do all different kinds of things, then you've got more experience that you can then apply to other languages, other technologies, other frameworks. So go really deep on fewer things early in your career. As you get that job, then you've got time to explore and learn and go do all that stuff. But to go get a job, focus on like one language, one framework, and just be your own expert. You don't have to be the expert
Hmm.
or an industry level expert, but be really good at what you know, like to where you're confident, like, I've done several projects in this language or in this framework or using this technology. I know it really, really well. Now I'm going to go interview, and I'm just going to tell them at that interview, I'm going to use these technologies. I'm going to go learn whatever else you need me to learn on the job, but this is what I know really well. And just
Right.
impress their socks off with what you know really well, instead of trying to, they want me to know Python for that interview. Now I got to go learn Python. It's like, well, you're not going to become a Python expert enough to pass their interview in a short amount of time.
Hmm.
So just go interview in JavaScript and say, I know JavaScript. It'll translate fine into Python. Um, and go from there. So fewer things, but go deeper on those fewer things to start up.
I dig it. I dig it. And I feel like our listeners will definitely be able to learn from that as well. And in a way that I've heard this as well is being there's a difference between being an inch deep and a mile wide than a mile
Mhm.
deep and an inch wide.
Yeah,
So that is
that's
something
exactly the
that
same thing. Yeah.
has really stuck with me over time. So
Yeah.
I really appreciate your time today, Ian.
Yeah.
And
Happy to help out.
yay, so much to learn.
Yeah, there's a lot to learn, but like I said, like focus on fewer things. There's also something that we call a T-shape engineer. So if you think about the T shape, it's very much like what you just said. You can go wide on things to a shallow amount, but on one thing you're going to go really deep and know that
Oh,
one
that's
thing really
cool.
well, where everything else is shallow. And so
Yeah.
be that T-shaped engineer early in your career. Like you can go learn like, okay, there's a database called Mongo, and there's a database called Postgres, and there's a database called MySQL, and there's a database called Redis. But you don't have to know them all really well. But you know what? I'm going to do everything in Mongo. So I'm going to learn Mongo really deep. And
Hmm.
now there's all these other programming languages, and I can, kind of read through them and understand prints and console logs and, puts and whatever for all these different languages. But I'm going to go really deep on JavaScript.
Okay.
And
I
so
did that.
be that T-shaped engineer, and just go really deep on fewer things.
I did that. And thank you again for the advice and all the learning and
Yeah, for
teaching.
sure.
And I hope we get to have you back again someday
Yeah,
to
for sure.
learn more about Postman too.
Yeah,
So,
we'll dig into what APIs are and how they're used and how
yes,
they hold the world together. And
yes,
yeah,
yes,
sounds
I'm
good.
excited about APIs.
All right. Well, happy Friday, everyone. We'll see you next time.
Thanks, Ian.